Hey, math people. I want to construct a 95% confidence interval, specifically for a small sample. So let me give you some backstory as to why you see me playing Beat Saber in the bottom right corner of this video. I teach statistics, and the year is 2020, setting the scene. So if you're a teacher in 2020 and I'm teaching seniors in statistics, this right now this is not cool because we're all staying at home. We have stay-at-home orders. This is remote learning, is what it's called. So what I'm asking my seniors to do is their last assignment is to record themselves doing a thing 20 times. Not like physically. You don't have to tape yourself doing it. I mean, record on a sheet of paper. Record numbers. Record 20 numbers. So these numbers should be normally distributed numbers. Numbers that if you were to run it, say 1,000 times, you would get a nice normal distribution. So some examples of ways to get normal distribution. Maybe your favorite level of Mario or something like that. Run that 20 times over, record how long it takes for you to do each level. That should be normally distributed. Perhaps standing on one foot for as long as you can, and recording the duration in which you stand on that one foot. Do that 20 times over. Or a high score in a classic game like Galaga. Just play through 20 times and rescore that number 20 times over. Just don't do something lame or something that really shouldn't work in this way to create a normal distribution, like rolling a die. That's not going to create a normal curve unless you do something fancy with it, like taking an average. But if you roll a die 20 times, that will not be normally distributed. So do something that will be that will eventually create a normal curve if you do it enough times. So for me, it was playing this song called Stronger on Beat Saber 20 times. And here are my 20 scores. You can see them right here. I'm using a program called R to store some of these and to do some of my calculations. But obviously, if you're a high school student, you don't have to do that along with me. We can do a lot of this calculations with pen and paper and using the trusty TI-84. So anyway, what I want to do is create a 95% confidence interval. 20 samples is not that much. Typically, the rule of thumb is once you're above, like, say, 30, you can just do a normal z-score value for a critical value. You don't have to use what's called a t-distribution. But if it's in the ballpark of the teens or 20s or even less than that, you have a small sample there, and you should be using a t-distribution for your critical value. So step 0 is to collect your data, have a sample standard deviation, and have a sample mean. So these can be easily calculated by hand, or you can use a software to do it for you. The TI calculator, if you go to stat and then you hit enter, what you should see is a list. You can type all these values into a list and then hit stat and then tab over to calc. And then one var stats will, it should give you the sample standard deviation and sample mean if you type, of the proper list that you put all those 20 values into. I used R. So you can see here that, and I'll just run these values right now. So I had 20 runs, so I said n is equal to 20. Here are all my scores. For fun, I'll show you the histogram as well. So I'm just going to run this. Here's my histogram of all my scores. This is roughly normally distributed. It doesn't create a perfect bell curve, and that's kind of the point. The point is, 20 runs is not enough to create a nice perfect bell curve. If I did this technically like 70 times in the same setting, assuming I don't get too bored or too tired or I master the song completely, assuming I just don't get better and I stay about the same, it would be normally distributed. So this is approximately normally distributed. You have some weaker tails and you have a good mass in the middle. It's just, you have a little void here, but I'm sure if I did enough runs, this would go up. Okay, so I just calculated my sample mean and my sample standard deviation. If we're curious for those numbers, I'll just run them. So I'm going to run this, and I'm going to run that. So here they are. My sample standard deviation is quite large. because the way that the points work in this game, it's just a very large number. So it's 24,235. And then my average score was 660,386. Okay, so I have my values. Most important values: sample mean and sample standard deviation. Next on the list is to find the critical value. So this is a small sample, so we have to do a t-distribution. The way that that works in a calculator, we would go to second vars, and inv t is the option for that. So I'll show that. Second vars. It's the fourth option underneath all the distributions it provides. And if you do hit enter on it, it'll ask you, well, okay, what's the area and what's the degrees of freedom? Okay, let's just, I'm like blinding you guys, aren't I, right now? There you are. It's asking for areas and degrees of freedom. Area is not too bad. It's asking for the area to the left of your area that you're looking for. So I'll show that in Paint. So if we're constructing specifically a 95% confidence interval, that's a great like default number to typically find a confidence interval of. This is a normal curve. And we'll say that 95% of the data lies from here to here. So this huge mass inside is 95%. You know, let's say you run this 1,000 times. I play this song 1,000 times. 95% of my scores will be in this mass. But I will have some bad songs, and I will have some good songs. So this is symmetrical. So the missing area is 5%. Cut it in half. This is 2.5%. Percent symbol. And then this is 2.5%. Okay. So what is it asking for? Is it's asking for the area to the left of your mass. So in which case, 2.5% is what the calculator is asking for. 0.025. Degrees of freedom. The way we find degrees of freedom, it's just your number of entries minus 1. So I ran the song 20 times. 20 minus 1 is 19. I just tell my calculator to calculate that, and I get a critical value of 2.093. Now I'm going to show you a few ways to get this value, because depending on what setting you're in, some teachers will say you can use a TI-84. Some teachers will say, well, you have to use a programming language. Or some teachers might say you have to use a t-table. So I'll show you the t-table approach right now. Nothing too crazy. As you can see, I already kind of highlighted the key numbers. You find the degrees of freedom, which is 20 minus 1, so it's 19. So it's always your number of entries minus 1. So if I, say, ran the song 28 times, my degrees of freedom would be 27. So I'd go all the way down to 27. But anyways, my degrees of freedom is 19. And then it's still the same value. This 0.025, it's the area to the right this time, but since it's symmetrical, it's all the same. The critical value here is 2.093. You'll see that that's how, and I'll circle it just to kind of put extra emphasis on where your eye should be. It's kind of that intersection between our degrees of freedom and kind of the criticalness of how confident we want to be. So if I wanted to be more confident, then I'm making my t-value quite larger. But if I wanted to be less confident with this interval, I would make the t-value much smaller, the critical value much smaller. So you can also run this in programming software. This is how you'd run it in R. So I will run this line of code, and I'll just kind of shoot out the value for it. And sure enough, I'm getting that same exact value I got the other two times, 2.093. So get that critical value. Next step is to calculate the standard error. So the standard error is calculated by this formula right here. It's nothing too crazy. All you need to do is take your sample standard deviation, divide by the square root of n. So in our world, what are we doing? We're taking 24,235.7, and we're dividing by the square root of 20 because there are 20 runs. So I'll do that right here. I end up getting 5,419.27. By the way, so again, these are large values just because that's how the game Beat Saber is. If you're playing around with smaller values, let's just say your mean is, say, 20, and your sample standard deviation is like 2 or 3, then you should be getting substantially smaller values. Normally, a standard deviation or a standard error like this would be quite large of an error, but it's not relative to where the mean is. So that's not too bad. That's how you calculate standard error. Calculating margin of error is the next step, and we use this formula right here. You'll note that this formula is simply taking the product of your critical value and your standard error. So that's exactly what I did here. You'll see this whole line of code. I store my critical value times my standard error as scores underscore error, and I'll run it. So this actually will be my margin of error, so how far away from the mean I expect to be for a 95% confidence interval. I should actually just copy this and run it. And you'll see it's a larger value, which makes sense because I'm multiplying it by the t-value, which, what did it come out to? It came out to that 2.093. So yeah, that makes sense. Now we want to construct a confidence interval out of this, and you construct it by using this expression right here. So it's the sample mean plus or minus the margin of error. So let's do the subtraction one first. I think that will be the easiest approach here. So I want to run just this lower one. So I'm going to take my sample mean, which was 660,386.6, and I'm going to subtract off the margin of error that I just found, which is 11,342. So ran that. My lower bound for this interval will be 649,043.9. And I can do the same thing for the upper bound here now. So I'm going to add the margin of error, and let's see what that comes out to. At most, I'll score 671,729.3 within this run, assuming I don't get much better, or assuming I'm not on full energy or something like that. Because I will say that I played this song the next day and I crushed the score. I got like 720,000 or something like that. And that's because it was a different day. So, there's that. I was full of energy, and I mastered the song by that point. So, these have to be independent. That's kind of the idea behind this. It's all these values need to be independent. So assuming I ran a 21st run, in this run of 20, I should score between, so I'm 95% confident that I would score a lowest score of 649,043 points and a highest score of 671,729 points. So seniors, that is your last task. Do something 20 times, record the sample mean and sample standard deviation, find that critical value, which, it's the same thing because we have that same area to the left, it's 95% confident, and we will have the same degrees of freedom, 19, so it's the same exact critical value. Calculate your standard error, margin of error, construct your confidence interval, and that's a wrap on your 2020 school year. Enjoy me playing the song Stronger. So this is if this is a copyright strike, shoot. I don't know. I'm playing a song in a game. I'm reviewing the game too, so I think I can do that, right? So my review of the game is that pretty good game. So yeah, that should cover me, right? Anyways, enjoy me playing Beat Saber for, I think this was on my 12th run or somewhere in the middle where I ended up getting my best score. Yeah, I'm going to ask you to continue to math on. I will do the same. I'll see you in the next video. 8 more to go. I don't say I eat like that very often, just so you know. It's not like a thing I do. I regret it. Moving on. I think you just gotta believe. Stance like you believe it. Yeah, I am stronger. Yeah, she's saying yes, I am stronger. Okay. Believe her. Believe in me. There we go at 198.
One missed notes, no problem.
Always having bad luck. You think you're going crazy. Look up, there's a new life waiting. Your head's buried in the sand. You've been dealt the wrong hand. Can't imagine how you feel. Only you know that it's real.
Whew.
Don't look back, just carry on, carry on, carry on.
Let's do this.
Because you are a stronger. Yes, you are a stronger. Because you are stronger.
It's for you, class of 2020. Woo! That was just one note. That was a shout out to all my drops. JK. If you dropped, that's okay. No hard feelings. Just think about it, you know, every day. That's also a joke. It's not like I had that many people dropping classes. I mean, let's do this. Ignore that. Play the game. Yeah, think about all the survivors. All of you guys that muscled through the pain and agony. Calculus, trig. All that jazz. It's 696, that's good. On stats, that's what I'm teaching right now, stats. That was really good. Alright, I don't think I'm gonna hit a PR like that again, so.